Hi everyone. In today's lesson, we are going to talk about how to write equations of lines using our favorite form of a linear equation, which would be slope-intercept form. So if you look at our directions here, they ask us to write the slope-intercept form of our equation when they give us an ordered pair that the line goes through and the slope of the line. So the easiest way to start these is to look at our ordered pair. So we're going to look at our first example here and label it x and y, because that's how ordered pairs are written. And then we know that our slope will be our m for y equals mx plus b. So we've got our m, and then we have an x and a y. And if you look at the slope-intercept form of an equation, which is y equals mx plus b, we know that we can put the m right here. But then when we write our equation of a line, we need to fill in the m and the b. And looking at what we're given here, there is no b value. And so what we're going to have to do is we're going to have to take our ordered pair, x and y, and plug it in for the variables x and y in slope-intercept form in order to solve for our y-intercept, which is b. So that's how we're going to start our example here, number 5. So if it helps, write out y equals mx plus b. And then we're going to go ahead and replace m with the number -1. We're then going to replace x with the number -1 as well, because that's what we determined that x equaled in this example. And then y we can replace with the number 3. The b is going to have to stay plus b because we don't know what it is. But now that we've plugged in x and y and m, the only variable left is the b, and so we can solve for it. So we will multiply the -1's together here, so that's going to be a 1 plus b equals 3. And then to solve for b, we will just subtract that 1 over the other side, which means that we get b equals 2. Be careful though, because that's not our final answer, right? The answer isn't b equals 2. They are asking us to write the slope-intercept form of the line. And so our answer needs to be in the form y equals mx plus b. So our answer will be y equals, right? We leave x and y variables for our final answer. We're going to put -1 in for m still. We leave x a variable, and then plus b, which we got to be 2. So y equals -1x plus 2 is our answer. That is the equation of the line that goes through the point -1, 3 and has a slope of -1. Example 6 technically, this second one here is the exact same type of problem, but I would like you guys to try that one on your own. So please pause the video here and work through this example to write the equation of the line that goes through the point 2, -5 and has a slope of -1/2. Once you get that answer, you can always raise your hand so I can check it or check with a neighbor to see if you got it right, but make sure you're showing your work as you get your answer there. In the next set of examples, we are still trying to write the equation of a slope-intercept form line here. It's just that now instead of giving us a point and the slope, they are giving us 2 points. So when we solve these kinds of problems where we don't have the slope or the intercept that we need, we've got to do a little bit more figuring out here. So let's start by step 1, finding the slope, or m, right? So step 1, we're going to find m, which is our slope. And to find the slope, if I'm given 2 points, we use that formula where we've got y2 minus y1 on top of our fraction over x2 minus x1. And those x's and y's come from our ordered pairs. So if you want to label your ordered pairs x1, y1 and x2, y2, you can. Honestly, it doesn't matter which one is x1, y1 and which one is x2, y2 though. So just remember that as long as you're kind of going the same direction both times on top and on bottom of this fraction, it doesn't matter. Let's follow along with what we wrote though. So y2 minus y1 would mean that we're going to take 0 minus 2 on top to find our slope. x2 minus x1 means we would take -2 minus -1. And be careful with that there because there will be two negatives right next to each other with the minus and the negative. So to simplify, on top 0 minus 2 is -2. On the bottom we have minus a negative, so that becomes a plus. So -2 plus 1 is -1. And then a negative divided by a negative is a positive. So we get 2 over 1, which is really just 2 for our slope. So there's our m, right? That's our slope of our line. All right then, there's our slope, our m. Now we need to find our b. And to find b, we're actually just going to do exactly what we did in this first example, where we're going to have to plug in an x and a y and our m to solve for b. So step 2, find b. And to do that, I like to start with the slope-intercept form, y equals mx plus b, and plug in everything that I can. I found that m was 2, so I can plug that in. And then I don't know b, but I can plug in a number for x and a number for y. And I get those numbers from one of these ordered pairs up here. The nice thing is it doesn't matter which one I choose of these two ordered pairs. You can pick whatever one you like. I think I'm going to pick the second ordered pair because there's a 0 in it, and zeros are kind of nice to work with. They make things a little easier sometimes. So using that ordered pair, x will be replaced with a -2, and y will be replaced with a 0. Now I just solve for b. 2 times -2 is -4. So 0 equals -4 plus b. And then to solve for b, I'll just add that 4 over to the other side. So it looks like we get b equals 4. So there is our b value, and now we have an m and a b, so we can write the equation of our line. Y equals 2x plus 4. That was our b. So that is the equation of the line that goes through the two ordered pairs, -1, 2, and -2, 0. Just like the earlier problem, I would like you guys to try the next example for the line that goes through 0, -2, and 3, 2. So pause the video here, try it on your own. Remember, you have to find m first by finding the slope between those 2 points. And then plug that slope and one of those ordered pairs in for x and y to solve for b. Make sure you write your answer as an equation in slope-intercept form. And I'm happy to check your answers before you move on. The second part of this lesson, we're still going to be writing equations of lines in slope-intercept form. It's just that rather than giving you a slope and an intercept, in these examples, you're going to be given a parallel or perpendicular line to the one we're looking for, and then also a point. And so we're going to be writing the equation of a parallel line through a point or a perpendicular line through a point. That's the last page. So before we get into that too far, I want everyone to remember what parallel and perpendicular are. Remember that parallel lines will never intersect or cross, right? Will never intersect. And they have the same slopes, right? They have the same rise over run. You'll see this symbol, 2 straight up and down lines for parallel lines. That means parallel. And then obviously parallel lines can look a lot of different ways. They could be both horizontal lines, both angled at a certain direction, right? This is what parallel lines look like. They never cross. They look like railroad tracks. Okay, so perpendicular lines, on the other hand, rather than never intersecting, they always intersect, and they make a 90-degree angle, or a right angle. So they make a 90-degree angle. The thing about their slopes, as you see in this example here, is they are opposite signs, and they are flipped. So I call it opposite flipped or opposite reciprocal. You may have heard that phrase before, for their slopes. And it just means that like the fraction 1/2, if I flip it over, it's 2/1, but then they also change signs. So it went from positive to negative. So that's kind of how you can determine the slopes of perpendicular lines. The symbol for perpendicular lines is like an upside down capital T. That means that lines are perpendicular. And obviously they can look lots of different ways. It can be two lines like this that would be perpendicular. Obviously they could be more angles, etc. But they're going to meet at 90-degree angles regardless. Okay, so to start, we're just going to find parallel and perpendicular slopes when I give you a different slope. So remember, parallel slopes are the same. Perpendicular slopes are opposite signs and flipped. So for example 1 here, if my slope of a line is 1/2, and I want to find a parallel slope, it's just going to be the same thing, the exact same slope. It's also going to be 1/2. To find the perpendicular slope, though, I'm going to flip it and change the sign. So 1/2, when I flip it, becomes 2/1, which is just 2, and then change the sign, so negative. So a perpendicular line to this one will have a slope of -2. Let's try another. In example 2, the slope is -3. So if I want to find a parallel line to that one, it would have the same slope, -3. If I wanted to write the equation of a perpendicular line to this one, then it's got to have an opposite reciprocal or flipped slope. So opposite sign, I know this one's going to be positive. And then flipped, that can be kind of tricky if you don't remember that -3 is the same as -3/1, right? Putting it over 1 does not change the value. So to flip that slope, it would be 1/3. And again, we make sure it's positive instead of negative because the sign has to change. All right, I want you guys to try numbers 3 and 4 on your own. And then let's talk about number 5 because that one's a little unique. Obviously, the parallel slope is easy because it's just the same as whatever it was initially, so that's 0. But for the perpendicular slope here, if we put 0/1, like you can do to make things fractions, right? You can just put it over 1, and then we flip it, we get 1/0. And the thing with 1/0 is that that's not allowed, right? We're not allowed to divide by 0 in math. So if you ever end up with a fraction with a 0 on the bottom, it's considered undefined. So this one has an undefined slope. In other words, if we were to graph this line, it would be a vertical line, right? It doesn't have slope. It would be no slope or undefined. Whereas our 0 slope would look like this. And it makes sense that those two lines would be perpendicular. Number 6 and 7. I think you guys can figure those two out. I would like you to do those on your own as well. Just remember that you have to find the slope first. So locate where is the slope in that linear equation, and then either keep it the same for parallel or flip it and change the sign for perpendicular. Okay, last 2 pages, we're going to practice writing equations of parallel and perpendicular lines through a given point. So for our first example, let's see. For our first example, we are writing the equation of a line parallel to this one. So it's important that we look at our original line and that we pay attention to this word parallel, right? We're looking through parallel, or looking for a parallel line. But our parallel line to that one has to go through the point 8, 3. So there's lots of requirements here that we have to pay attention to. Luckily, you can see the steps right at the top of the page to help you out if you're stuck. But step 1, make sure you're given the original equation in slope-intercept form. If not, you might have to solve for y. Then we're going to borrow the slope, right? Our slope is going to be the same as this equation's slope because they're parallel. That's why we're just picking the same equation. So we know that this right here is the m we're going to use for our answer. Well, now that we have m and our x and y that our line needs to go through, we can do kind of like we just did earlier, where we're going to plug in the slope and an x and a y into slope-intercept form so that we can solve for b and find our y-intercept, because remember, this y-intercept here is for a different line. We don't care about that one's y-intercept at all. We just needed that equation for its slope. So the equation of a line, y equals mx plus b, we need our slope to be 3/4 so that it's parallel to the other line, but we need it to go through the point 8, 3. So we need to plug in an 8 for the x and a 3 for the y. Now we solve for b. So let's multiply 3/4 times 8. 3/4 times 8, a couple ways you can do that. You can take 3 times 8, which is 24, and then divide by 4. 24 divided by 4 is 6. Or you can think of it as 8 divided by 4 is 2, and 2 times 3 is 6. So either way, you get 6 plus b here equals 3. Let's subtract that 6 over, and it looks like we end up with b equals -3. Now remember, that's not our answer. Our answer is when we get the equation of the line, right? That's what they're asking for, that goes through the point 8, 3 and is parallel to the original line there. So we're going to have y equals, we need that 3/4 slope, x, and then our b is -3. So there we have it. Y equals 3/4 x minus 3. I'd like you to try example 2 if you're feeling confident before I do it, but I will do the example 2 for you here as well. So once again, example 2, we're looking for a parallel line. So we know that we are going to be using the slope that's given to us in this equation. So our slope needs to be 3/7. So m must be 3/7. And then it has to go through the point 7, -2. So there's our x and y. We will plug both of those and m into y equals mx plus b. So y is going to be -2 equals m is 3/7 times x, which is 7, plus b. 3/7 times 7 is just 3. And then let's subtract that 3 to the other side. So you should have ended up with b equals -5. Putting that together with our slope means that our equation is y equals 3/7 x minus 5. So hopefully that is what you got as well. You guys will for sure need to try the last example on your own, and then either have me check it in class if you're in class, or check it with a partner, or ask me the next time you see me. The last page then is how do we do this when the line is perpendicular rather than parallel? And this we have to be really careful with, because we can't just take the slope from the line they give us if it's perpendicular. Because perpendicular means that we need the opposite reciprocal slope. So just be really careful. We're not going to use 3/4 in our answer. We're going to use -4/3 for m. And then for our x and y, we're going to do that the same way. We're going to see the point that we needed to go through and use those numbers for x and y. So the only change here is that that slope we use for our answer has to be opposite sign and flipped from the one they give me. The rest is the same. So we write out our y equals mx plus b and plug in what we know to find what we don't. So we're going to plug in -2 for y and 6 for x. We've got our slope is -4/3. And now we just solve for b. So -4/3 times 6 looks like would be -8 plus b equals -2. Add that 8 over to solve for b. So it looks like we get b equals 6. And therefore the equation of our perpendicular line to the one they gave us is y equals -4/3 x plus 6. just like the previous page, see if you can try example 2 on your own and get it to match what I'm about to do. And then you'll do example 3 on your own as well, and that one I'm not going to do in the video. You'll need to do it on your own. So for example 2, if you're ready to see the solution, we need an opposite reciprocal slope to the one they give us for this line because we're looking at something perpendicular. So our slope that we're going to use is -7/3. Our x and y are 3 and -1. So for the equation of our line, y equals mx plus b. Y is -1, x is 3, and then our slope is -7/3. To solve for b, we'll multiply these together. So that's -7 plus b equals -1. Add the 7 over. And oddly enough, it looks like we end up with the same b value in this equation. I think that might just be coincidence. But we get b equals 6 here as well. So our final answer, our final equation for this example is y equals -7/3 x plus 6. All right, guys, great job. Like I said, make sure to try the last example on your own, get the answer, and check it with me.